HK-5921A VPC Vapor Phase Coker to test coking propensity of aviation lubricants. Applicable standard HK-5921A Vapor Phase Coker to test coking propensity of aviation lubricants meets the requirements of the test method specified in VPC Meteorological coking evaluation method and is applicable to evaluating the coking tendency of grease-type synthetic aviation lubricating oils in the mixed state of air and oil phases to simulate the state of the vent type of the bearing chamber. Main technical indicators: 1. Power supply AC 220伏，15%赫兹。2. Power 220W 3. Oil heating method heating jacket automatic heating power 700W 4. Test tube heating method metal back heating power 120W 5. Constant temperature accuracy plus or minus 1 degree centigrade 6. Flow rate 7,655 milliliters per minute 7. Environmental requirements temperature 5到40摄氏度 humidity 小于等于85%。Instrument functions and composition: air inlet, gas shutoff valve, gas water separator, pressure stabilizing valve, high pressure safety valve purifier, buffer function port 2, flow shutoff valve, function port 1, flow controller solenoid valve, low pressure safety valve, gas outlet, heating furnace, test tube installation port, bath temperature sensor installation port, touchscreen USB port, power switch, fuse installation position, power cord connection port, heating jacket aviation plug, and heating furnace aviation plug. Instrument accessories include lifting frame, wrench, test tube, air release device, power cord heating jacket, test tube heat preservation cover, ventilation PU tube glass air guide tube, free neck flask adapter null 8 sensor, null 7 sensor, test tube sensor purifier, and filter element. Instrument installation: connect the heating jacket aviation plug, connect the heating furnace aviation plug, connect the solenoid valve aviation plug, connect the power cord, and connect the air source to the instrument cell inlet pipeline. Clean the water in the gas water separator to ensure it is clean. Install a new purifier filter element on the purifier. Place the lifting frame on the test bench and the heating jacket on the lifting frame. Connect the flow controller communication line. Gas purge of experimental pipeline. Open the inlet valve and adjust the secondary pressure gauge to 0, 3 to 0.4 megapascals. Adjust the pressure stabilizing valve to 0.2 MPa. Install an air release device at function port 2 to complete a gas release and discharge the gas in the system. Experiment operation demonstration. Turn on the instrument's power switch. Weigh and record the mass of the treated test tube. Install the sensors on the test tube in the order from null 6 to null 1, null 6 first, then null 1, according to the position shown on the screen. Install null 7 sensor on the heating furnace. the sensor should be inserted into the installation hole. The sensor had a fault test. Unscrew the ferrule nut and check whether the ferrule core is installed in the ferrule. Place the heat preservation cover above the heating furnace and insert the sensor into the heating furnace through the heat preservation cover on the upper part of the heating furnace. Press the test tube down steadily to ensure its bottom is inserted into the heating furnace ferrule core. Gently tighten the mounting nut with a wrench to ensure the test tube does not move before the nut is loose. Visually inspect the connection between the upper part of the heating furnace and the lower part of the test tube heat preservation cover to ensure there is no obvious gap. Pour 900 grams of sample into a cleaned and dried 2000 ml empty flask, accurate to 0.1 grams. Place the 3-legged flask with the sample into the flask heating jacket and close the heating jacket. Apply vacuum paper to the adapter and place it into the middle straight port. Insert null edge sensor into one of the inclined ports and the glass air guide tube into the other inclined port. Adjust the lifting frame to make the adapter at the middle port of the 3-neck flask tightly fit with the electric furnace. Connect the air guide tube to the gas outlet with a hose and tighten with a wrench. Connect the connecting plugs between the sensors on the test tube and the controller in a 1-to-1 numerical correspondence. After connection, place the connecting wire at the rear of the instrument to avoid scalding. Enter the sample number and click Confirm. Enter the steel tube mass and click Confirm. Enter the sample mass and click Confirm. Open the flow shut off valve through function port 1 to replace the gas in the pipeline. Click Start Experiment. Click Flow Setting to set the required flow rate, and the screen displays the airflow rate in real time. The instrument automatically starts timing. After the timing ends, the instrument automatically stops heating and timing automatically cuts off the air source and enters the cooling process. Click Experiment Data and Curve to view the experimental data curve. Click Data List to view curve data. Click Return to go back to the main page. After the experiment, close the flow shut off valve and gas shut off valve. Install air release devices at function port 2 and function port 1 respectively to empty the gas in the pipeline until the gauge pressure is on. Then remove the air release devices from the function ports. Lift the heat preservation cover. Loosen the nut fastening unit. Gently tap the test tube. Carefully take out the sensors and the test tube. Remove the sensors from the test tube and soak them in hep tonic for 30 minutes. Take out the test tube after drying for 30 minutes. Weigh it accurate to 0.1 milligrams and record. Take out the 3 neck flask according to standard. Requirements: weigh the flask and the test oil accurate to 0.1 grams and record. Loosen the fixing screws with a wrench and remove the fixing frame. Install the washer on the first screw on the left side of the fixing frame. Install the test tube into the slots of the front and rear fixing frames. Tighten the fixing screws with a wrench in the order from left to right and ensure the gear lever is at position. Then turn on the power switch. After the motor starts, adjust the gear lever to an appropriate gear. Recommended gear 3. Rotate the operating handle counterclockwise to move the saw blade to the initial cutting position. Rotate the hand wheel slowly to make the saw blade cut the test tube slowly. Too fast will cause severe vibration of the test tube until the test tube is completely cut. Push the gear lever to position all. The saw blade stops working and turn off the power switch. Rotate the handle clockwise to return the saw blade to the initial position. Remove the cut test tube and observe the caulking situation inside the test tube. Saw blade replacement. If the saw blade becomes dull due to long-term use, it can be replaced. Open the upper operation box. Rotate the handle counterclockwise to lower the pull disc to the lowest position. Open the lower operation box door. Remove the saw blade, replace it with a new one, and install it according to the method in the video. Clamp the saw blade in the upper and lower discs and push it to the slot position. Rotate the handle clockwise to tighten the saw blade. Close the upper and lower operation box doors to complete the saw blade replacement. End of experiment operation demonstration. Welcome to use Huic Instruments. Goodbye.